In example 3.3, we're going to be looking at two maps on the same Cartesian coordinate plane. The first map is called F, and it tells us here that the domain of F is going to be all real numbers. So because the domain is all real numbers, if you didn't already know about the limitation of my graphing software, then this would also help to tell you that you should be putting arrows at the edges of the window. Same thing would be true about map G. G also has a domain of all real numbers, so we should be going beyond the viewable window with this graph as well. So that's what we get there. So it says use the given graphs of f and g to solve each equation. And the first equation says f of x is equal to g of x. So we want to know what x values are going to make this equation true. That's what we're after. So let me diagram this for you from an arrow map perspective. So each one of these graphs can be thought of as that arrow map. So let me draw a picture for f. So we have first set, second set. The first set is the set of real numbers. Second set is also the real numbers, and we can call that f. And g is going to look just the same. Real numbers mapping to real numbers, call it g. But what we're describing here is that there is some x value that's going to map to an f of x value, and there's going to be some g value that, or excuse me, some x value that maps to a g of x value. And what I want to know is which x value can I use so that way this f of x and this g of x are identical. I want to know where they are equal. That's what the equation says. Where will f of x be equal to g of x? So remember that the second set is going to be the y values, and that the first set is all of the x values. So I'm really wanting to see where are the y values going to be the same, and then I'm going to state which x values that occurs at. So from a graphical perspective, because we don't have the actual equations for what f and g look like, all we have is the graph. So what that ends up translating into is the places where we have intersection. If I look at this point right here, that point would be the point 2, 1. And this other point would be located at -1, -2. Now it doesn't matter which map you look at. You're going to get that same answer for each one of those x's. So if I look at my map, I say, okay, let's pick 1 for f, for the first set of f. And over here, oh sorry, not 1, let's pick -1. And if I look at f, -1 is going to map to -2. And if I pick the same x value for the first set of g, -1 is still going to map to -2. I get the same result no matter which map I look at. So that's why the intersection is such an important point, or points in this case. There's 2 points of intersection. So we can state that the answer to this first part, part A, is going to be the x value -1 as well as the x value 2. These are the two x values where these functions are going to share the same value. Another way that you can write that is using the set notation -1 to +2. You can write it like that. So part B is going to build on what we just described. So let's take a look at the next part. F of x is less than or equal to g of x. So we do have that equal to, which would be identical to what we were discussing in part A. We already know where that's happening. That's happening at the intersection. But we're really looking for also where it's going to be less than. So let's think about that. Let's pick another x value. Let's say we pick, I don't know, 0. Let's say we pick 0 right there. So 0 is going to translate to this point on G, and it's going to translate to this point on F. Well, at this point on F, the y value is -3, And at this point on G, the y value is -1. So the y value for f is less than the y value for G. So this is a good place for us to look at. In fact, there's a whole host of places where this relationship would be true. If I pick all of these points on G, or excuse me, on F, and I compare them to all of these points on G, then every point for F is going to end up being below the corresponding point for G. So that shows the relationship that I want to have happen. So if I want to translate this into the solution set, I have to think about what are all the x values that we're using here. So on the far left, where the intersection begins, we know that that is an x value of -1. Where the other intersection occurs on the right side, that has an x value of 2. And the relationship that we're looking for is in between these 2 points and including the 2 points. So everything from -1 to +2 is going to be included in this. So my solution set has an infinite number of values, therefore I need to represent it using interval notation, going from -1 to +2. Now let's take a look at part C, which is going to also build on our understanding of part A and B. Now let me clear the board, clear the graph. And with digital ink, this is easy to do. I know on your own paper that's not quite so simple. But it says, I want to find all the places where f of x is going to be greater than g of x. So to find where it's greater, it's really helpful to know where they're equal. So I know that they are equal here, and they are also equal here. Now let's say that I pick 2.5 on the x-axis. So I'm going to start at 2.5 and I'm going to carry that up to G, and then I'm going to carry that up to F, and I'm going to notice that F is larger than G in terms of the y value. The x value is the same, but the y value is larger for F than it would be for G. And that's precisely the relationship that we want. We want the F to have a larger value than G at that particular x. So that would be one place where this relationship is true. But if you look at the trend, that would mean actually all of these points and all of these points would exhibit that same behavior. So translating that down to the x-axis, I would put an open circle at 2, because I really don't care where they're equal. I want to know where f is greater than g, and then that would happen everything to the right of +2. But that would not be the only place on this graph where that occurs. If I go over to the left intersection point, I can look at, say, an x value of -2. And if I carry that up to f, and if I carry that down to g, I can see that the same relationship happens. The y value at f is going to be greater than the y value at g. But again, that's only one x value. There's a whole bunch of other x values where that same thing occurs. So anything to the left of this intersection point is going to exhibit the relationship that we want. So going to the x-axis, I can represent that open circle at -1, and then everything to the left of -1. So we will write that using interval notation as well. That'll be -5 to -1, or excuse me, not -5. It's going to continue on forever. So that needs to be -infinity to -1 union +2 to +infinity. And that will represent all the x values where the y value for f is going to be greater than the y value for g.